Okay guys, today we are doing 6.3 solving trig equations. So with this, solving means what value makes the statement true. I'm not going to worry about that first quadrant right now because you should have your unit circles ready with you. Okay, so what we are going to do is we are going to restrict our solutions to the whole unit circle. Okay, just the unit circle. As you can see, guys, 0 is included, but not 2 pi. So make sure if what makes it true is 2 pi, that you're just putting down 0. So in A, we are finding the values of x that make the statement true. Okay, we are using radians. So grab your unit circle. Sine is the second part of the coordinate, and we are looking for 1/2. So as you can see, I found 1/2 right here, which is pi over 6. And then we are looking for 1/2 again, because that's not the only spot, but 1/2 in the second part of the coordinate, the y part, is right over here. So the radian is 5 pi over 6. So it's what makes this statement true for the whole unit circle. B, where is cosine, or cosine of what is -1? Well, cosine is the first part of our coordinate. So where is the first part of our coordinate? -1. Let me see it at pi. Anywhere else? Nope, just at pi. So in this case, there's only one answer. Now, last class, you should have added tangent to your unit circle. If you have not, this is going to be harder to see. So we are looking for where is tangent, or what makes tangent negative square root of 3 over 3. Okay, well there's positive right there. So where is it negative? We have a negative at 5 pi over 6. And let's check if there's any more. Negative. There's a positive one. And there's the negative at 11 pi over 6. So again, what makes it true? And no, I'm sorry to tell you, that's not all that's left. We do have to make this a little bit more difficult. So, what's different from example 2 than example 1? Well, as you can see, there's other things that are going on with the trig function. So what we're going to do is isolate the trig function. In A, the first step we're going to do is add 1 to both sides. So I'm left with 2 sine x equals 1. And how do you get sine x by itself? We divide both sides by 2. So I'm left with sine x equals 1/2. Now I can use my unit circle and find where sine would equal 1/2. So again, we have pi over 6 and 5 pi over 6. For B, we have 2 trig functions. We have to make it into 1 because we want to get it by itself. So the first thing I'm going to do is subtract 3 cosine x from both sides. You got to remember, if there were 5 and now we're getting rid of 3, that means there are 2 cosines left. And on the right side, we have square root of 3. Next, we need to get cosine by itself by dividing by 2. So I'm looking for cosine giving us square root of 3 over 2. Positive square root of 3 over 2. So if we look back at our unit circle, I see it at pi over 6. And let's look for that square root of 3 over 2 in that first part of the quadrant. There's a negative. There's a negative, but we want positive, so 11 pi over 6. Alright, make sure you have your calculators out, because this is the next one we have to use technology to help us. Okay? What we're going to do is we're going to find all the solutions from 0 to 2 pi. So first of all, you want to make sure that your calculator is in radians. So go to mode and make sure you're in radian right there. Next, go to y equals. And I have some calculus stuff on there, so I'm going to get rid of it. What we're going to do is put the left side into y1 and the right side into y2. Okay, so I'm going to say cosine x, and y2 I'm going to put down 0.75. Okay. Now let me change my window, because all we care about is from 0 to 2 pi. Let me get back there, sorry. 0 from 0 to 2, there we go, second, pi. Now, we want it at 0.75. So what I would do, guys, is I would make sure that 0.75 is somewhere in the middle. So let me go from, oops, I want the scale to be 1. Let's go from 0.1 to 1. Okay, that will make 0.75 somewhere in the middle. So now I'm going to graph. There's my cosine. What's graphing right now is my cosine. Okay, and there's the 0.75. We want to know when this is true, when they equal. So we're going to find the intersection at second trace. Go down to intersect. Now, what you want to do is I'm going to press the down button, because as you can see, it says y1. So that little flashing dot is going to follow cosine. But that's a little hard when it goes everywhere. So I'm going to change it to where it says the 0.75. And there's the flashy dot. I need to get it close to the intersection. And then I press enter 3 times. 1, 2, 3. So my solution is x equals 0.72, and let's see how far we're going to go out. Let's do 3 decimal places, guys. So 0.723. And there's another one, right? So I have to do that again. Second trace, intersect. Make sure it's on the 0.75 line, because that's easier. I'm going to press the right arrow until it moves all the way close to that intersection. And press enter 3 times. 1, 2, 3. So I get x equals 5.56, and it would be 0. Let's try that one more time. Okay. So I'm going to go to y equals, and this one's going to be tangent x And the bottom here is going to be negative 0.79. Window. My window, I do need to change. This is 0 to 2 pi, which is great, but negative 0.79 is not going to show in my y value here. So maybe I will go from negative 1 to, let's say, 0.1. So I'm going to switch it this time so that negative shows. If you graph and you can't see that horizontal line, it means we have to change the window. This takes time and practice, so make sure if you're not getting it, call me over so I can show you. I'm going to graph. There's my tangent. Oh, there's 2 of them there, and there's my horizontal line. So if you don't see that horizontal line, guys, call me over right now. And then I do my intersections again. So second trace, intersect. I'm going to make sure that I am on the negative 0.79. Get really close. Press enter 3 times. So I get x equals 2.472. And there's another one in there, so I'm going to find that out. Second trace, intersect, change my curve, go over. One, two, three. Okay, and we get 5.615 when we round up. All right, you're all set to start your practice.